Greetings to all. In today's session, we are going to discuss about intermediate chemistry, which is international important towards entrance examinations or any competitive exam, India level JEE advanced exam and JEE mains examination, NEET chemistry that is for medical entrance examination, Telangana and Andhra Pradesh EAMCET examination. So for all these examination, the content what we are going to discuss will be very much helpful. And moreover, the people who are aspiring for any competitive examination, there also this will be very much helpful. Let's enter into our question number 1. When butane 1-ol, CH3, CH2, CH2, CH2OH, this is called butane 1-ol, is passed over the catalyst silicon 4 oxide, oxidation state around the central silicon is given with 4, so that we can say silicon O2, SiO2 it will be. Water is lost. Whenever butanol upon treating with silicon oxide, what loss of water molecule is possible, deduce the name and structural formula of organic compound in this reaction. Name and structural formula are required to be filled, right? So whenever water lost, so that we will get a dehydrated product called alkene. That alkene might be butanene. The process is called dehydration, and SiO2 is the silicon dioxide. It is the dehydrating agent. OH from this carbon number 1 and hydrogen from carbon number 2, so that water will be removed and we will get 1-butene, unsaturated alkene as the final product. Let's move on to question number 2, where you can find the primary amine CH3, CH2, NH2. This is called ethanamine. As per IUPAC, called ethanamine. Upon reacting with hydrochloric acid, always based on reaction with an acid, neutralization gives rise to the salt, so that the compound will be ethyl ammonium chloride. This is the specimen reaction in order to solve the second equation. The question is given as ethanamine upon treating with sulfuric acid. Sulfuric acid will be the reagent here. What will be the product formed? Name of the salt we have to mention. So for that purpose here, ethanamine is treated with sulfuric acid. Sulfuric acid is the acid used to be treated with this one. Protonation gives rise to, so here ethyl ammonium. NH3 is called ethyl ammonium, and being sulfate is bivalent, so that these molecules can be taken twice, so that ethyl ammonium sulfate will be represented in this manner. In order to get this, we have to take 2 moles of ethanamine. 2 moles of ethanamine upon treating with sulfuric acid, ethyl ammonium sulfate salt formation is possible. Let's go with the question number 3. Again, it is the part of organic chemistry and related with the aromaticity of the given compound. Which compound among the following is not the aromatic compound? So we have certain rules and regulations to mention the aromatic nature. There are 4 guiding principles which gives the aromaticity to the given compound. Okay, and the first compound is cyclopentadienyl anion, and this is tropylium cation. Cycloheptatrinyl cation is called tropylium cation as a common name, and this is cyclopropene cation, and here we have cyclohexatriene. There is no ion is there. Simply you can see it is CH2 carbon, right? Among all these 4 options, which is not aromatic to be mentioned, and the right answer will be option number 4. Why we can say option number 4 is not aromatic? For that, let's go with the 4 rules and regulations. The compound must be cyclic. If you see all 4 options, all are cyclic in nature. And second, the molecule must be planar. This is not obeyed. This is omitted by the option number 4. If you see option number 1, all the carbons are sp2 hybridized, so that planarity can be retained. Compound 2 tropylium cation also planar, because of all the carbons in this ring are sp2. In this third compound also sp2 hybridized, but in the fourth compound, all double bonded carbons are sp2, whereas the CH2 carbon is sp3 carbon. If you see this CH2 carbon is non-planar due to sp3 hybridization. The second point is not obeyed by the option number 4, so that it is non-aromatic. Conjugated. if you see this, there is a conjugation. Negative charge is in the conjugation with the 2 double bonds. Positive charge is in the conjugation with 3 double bonds. Positive charge conjugation with 1 double bond. Here conjugation also lost. Third point is also not obeyed by the option number 4, where you can't find. Conjugation means alternate availability of double and single bonds. That also lost in option number 4. And the last point is the molecule has 4n plus 2 pi electron system. 4n plus 2 pi electron system means n means number of rings, right? So n will be integer value, right? 4n plus 2 pi electron system is present in this. So if you substitute 4 into 1 plus 2, it is the 6 pi electron system. Or this is the 6 pi electron, this is the 6 pi electron, this is the 2 pi electron system, and here is the 6 pi electron system. So all compounds are obeying this one. 4n plus 2 is not obeyed by option number 3. 4n rule is obeyed by the option number 3. But so option number 2 and 3 are not applicable to compound number 4. So that we can say it is non-aromatic in nature, right? That is purely because of non-plenarity at this carbon. And second is conjugation is lost in this compound. Go to the question number 3 completed. Move on to question number 4. The IUPAC name of the element with atomic number 119 is, right? As of now, 118 elements are available. 119 is a new element to be invented. So what could be the IUPAC name, which is which is present 119th element? Okay. So for that purpose, we have this extent of table, and in this up to 118 only mentioned, so that the question is given as a 119th element, right? So from this table, we have to predict. So if 1 is there, you can mention it as un, and 0 is there, nil, and 1 is there, anium. Okay, nil, anium is for 101. Using this kind of terminology, we have to assign the name for atom number 19th. For that purpose, here 1 means un. So that let's put un. And again 1 means again un. So that un. And 9. If 9 is there, its suffix is given as innium. Sorry, it is called innium. Innium. This is the IUPAC name of the compound. Okay, so because we have twice 1, so that un is the continuation, and 9 is there in the terminal, so that NEM will be there. Innium is the IUPAC name of a 119th element. Innium is provided in option number 1. For question number 4, option number 1 is the correct answer. Let's go to the question number 5. Which of the following compound has highest hydration energy? Right? Hydration energy is inversely proportional to size. Largest hydration energy, smallest will be the size. Among all, beryllium. So here, all these are elements. If you observe, all these are the elements of main group 2. Beryllium, calcium, strontium, barium. So that main group 2 elements. So top to bottom, if you observe the radius of the cation will increased, so that beryllium sulfate is the tiniest, calcium sulfate is slightly largest, strontium sulfate is still larger, and the largest one will be barium sulfate. So that as we are descending, size of the salt will increases, size of the ions will increases. That's the reason why smaller the size accorded for the beryllium sulfate, hence highest hydration energy will be given. For question number 5, option number 1 is the right answer. Let's see why it will be. A smaller the size of ions, higher the hydration energy. For example, ionic size of sodium and lithium. Lithium is the tiniest, sodium is the largest, right? Therefore, hydration energy of lithium is minus 520, and sodium is a minus 405. It's clearly depicted that lithium is having larger hydration energy because of smaller size. Smaller the size, larger the hydration energy. So that beryllium sulfate is the correct answer. Let's move on to the last question of the session, where the correct statement from the below. Here, H3BO3 is called boric acid. When this boric acid is taken, what kind of nature you can see? Boric acid used in the carom board for easy moving of coins. And being it is a solid, it's a very clear, it is the crystalline solid, everybody aware about, so that we can cancel out the option number 1. It is not the liquid. So that option 1 containing will be completely compatiated, so that only option A is having 1 and 2, so that we can cancel out this one. Then boric acid is a liquid is the wrong one. H3PO3 forms a layer structure. Yes, it is the correct answer. That's the reason why it is having sliding nature. If you strike the striker in the carom board, it is moving very smoothly. That is because of it's a layered structure. It is having sliding nature, right? So boric acid is having what a layered structure like this. Such layers are available in that boron. So here the option number 2 is the correct explanation for boric acid. Boric acid, BO3 units are joined by hydrogen bonds. So obviously oxygen and hydrogen, if present, there is a possibility of the formation of hydrogen bonding in this manner. If you observe, boric acid is connected with all remaining boric acid molecules by the stable forces called hydrogen bonding. Hydrogen bonding will be depicted in the boric acid, so that due to the presence of hydrogen bonding, the molecule will become more stable. So that option number 3 is also the correct answer. H3PO3 is the tribasic. Basicity of any acid can be given as ability to release H plus ions, but H3PO3 is not releasing any H plus ions out, rather it is accepting electrons inside, right? Boric acid, also known as orthoboric acid. Boric acid contains 3 OH groups, but it is not considered as tribasic, rather we can say monobasic acid. That is because boric acid does not act as a proton donor. It is not releasing any protons out. If protons release, then only it is called the monobasic, dibasic, tribasic, like that. But rather boric acid is able to accept the lone pair of electrons given from this water molecule, so that we can say monobasic Lewis acid. Monobasic Lewis acid it will be, right? So from this, liquid is the wrong statement because it is the crystalline compound. Layered structure is the right explanation. Here hydrogen bonding is available. Tribasic is not possible, rather it will be monobasic. So 2, 3 correct explanation, 2, 3 are provided in the option number 2. For question number 6, option number 2 will be the right explanation. By this, we completed the session and hope this session will be very much helpful for your content preparation. And I'm requesting you to like the channel, comment over here, share with your friends, subscribe the channel for more updates. And thank you very much for your patient listening. Thank you one and all.